So today we have a nice geometrical problem. We have three squares that are arranged in this specific pattern as you can see in this diagram. And the point you have to note is that the line segment AS is a straight line, or we can even say the point A, the point R and the point S are collinear points. Now using this given data, you have to find the ratio of area of the yellow square to the area of the red square. So let us see the solution. How can we find this particular ratio? So first of all, we can see that the side lengths of these three squares are not given. So we will start the solution by taking their side lengths as variable. So let the side length of the biggest square, that is the blue square, be equals to k. The side length of the yellow square be equals to x, and the side length of this red square be equals to y. Now the required ratio that we have to find is the area of the yellow square to the area of the red square. Side length of the yellow square is x, therefore area of the yellow square is x square, and as the side length of this red square is equals to y, so area of the red square would be equals to y square. So the required ratio is ultimately equals to x square upon y square, that is x square is to y square. So now our goal is to find the value of x square upon y square in this particular solution. So let us see that. So for that we can use this particular pattern in which these squares are arranged. We can see that the corner of this red square is joined with the corner of this blue square, that is the biggest square. We can also note that this corner is touching the side length of this blue square, and over here these two corners are together. So we will utilize these three facts. So what I will do is draw a line segment from A to C and from A to Q. So these are the only two line segments that we need in our solution, and now we have to take some of the angles also. So I will take the angle CAS as some variable, let it be equals to theta. In this diagram, the angle CAS is this particular one, and I am taking it as a variable theta. Okay. Now what can you say about the line segment AQ? So if you will observe carefully, you will note that the line segment AQ is the diagonal of this yellow square, and as we all know that the diagonal bisects the 90 degree. So over here this complete angle is going to be 45 degree, as this is the diagonal. Now this much angle is theta, the bigger angle is 45. So this remaining angle is going to be 45 minus theta. So I'm writing it over here, that particular angle over there is 45 minus theta. Now this bigger 45 is not needed, so I'm just removing. Now what can you say about the line segment AC? So again, if you have observed carefully, we can note that the line segment AC is the diagonal of this blue square, and again a square, a diagonal, so it will bisect the 90 degree as 45 degree. So from here to here the angle is going to be 45 degree. This much angle is already 45 minus theta that we have noted over here. So this remaining angle is going to be 45 minus 45 plus theta, that ultimately gives us theta. So that is the only required angle, so I'm just removing this 45 again. This 45 minus theta is also no more needed. The only required thing was to find that particular angle same as theta. So as per the calculation that we just did, we get that the angle BAQ is also going to be equals to theta. So these are the two required angles. Okay, so here we have marked some of the important line segments and some of the important angles. Now look in this triangle ACS. In this particular triangle, angle S is 90 degree because it is the corner of the red square. And now look in this triangle AQB. In this also, angle B is 90 degree because it is the corner of this blue square. Now from here we can have two solutions. The first solution is using the similarity. We can easily say that triangle ASC is going to be similar to triangle BAQ by the property of angle, as in this triangles two angle is equal, theta and 90 degree and 90 degree. So as we can see that these two triangles are similar, so we can do the corresponding part of similar triangle and obtain the sides as ratio and do all the further calculations. But what I am thinking is to use trigonometric, because these two triangles are right angle triangles and they are having a common angle theta. So using trigonometric would be a nice method. So now look in this particular triangle, this side is y. What can you say about this particular side? So from A to R, it is the side length of the yellow square, so it is going to have a length x, and from R to S, it is the side length of this red square, so it is going to have a length y, because in square all the sides are equal. Now what can you say about the side length AC? As AC is the diagonal of the blue square, side of the blue square is k, therefore the diagonal of a square is going to be square root of 2 times the side, that is square root of 2 times k. So in this particular right angle triangle, we have all the three sides, so I am drawing the same right angle triangle over here. So this is the point A, this is the point S, and this is the point C. This is 90 degree, this angle is theta, this side is square root of 2 times k, the base is x plus y in total, and this height is having a length y. Now look in this triangle BAQ. So I'm drawing that particular triangle over here also. So here is the angle B, Here is the angle A and here is the point Q, and this particular angle is theta. Now the hypotenuse of this particular triangle is AQ, and AQ is ultimately the diagonal of this yellow square. Side of the yellow square is x, therefore diagonal is going to be square root of 2 times x. From point Q to the point B, the height is not specified, so we will not mark it also. From A to B, it is the side length of the blue square, so side of the blue square is k, so the length of AB is going to be k. I have not marked the height because in these two triangles the angle theta and theta is equal, and I am going to equate the cosine of that angles. So what we need is the base and the hypotenuse. So as I told you, we are going to compare the cosine in these two triangles. So from this triangle, the value of cos of theta is going to be adjacent upon the hypotenuse, that is x plus y upon square root of 2 times k. And from this particular triangle, the value of cos of theta is going to be equals to adjacent upon hypotenuse again. Adjacent is k and hypotenuse is square root of 2 times x. Now in this equation and in this equation, the left hand side is equal, that is cos theta and cos theta. So we can simply compare their right hand side. So the right hand side of this one is going to be right hand side of this one, that is going to be k upon square root of 2 times x. Now we can see that square root of 2 got cancelled out. After cross multiplication, we will get x into x plus y is going to be k square. So this is the first important equation, that x into x plus y is k square. Now let us utilize it by applying the Pythagoras theorem in this particular triangle. Why not in this triangle? Because this side is missing, and in this triangle all the three sides are available, so we can simply apply the Pythagoras theorem. So as per the Pythagoras theorem, the base square, so x plus y the whole square, plus the side square, that is y square, is going to be hypotenuse square, that is square root of 2 times k the whole square. Now let us open the brackets in the left hand side. So x plus y the whole square will turn out to be x square plus y square plus 2xy plus y square as it is, that is this y square, and this thing is going to be 2k square. Now we have the value of k square, that is x into x plus y, so we can replace this k square with that particular value. So 2 times x plus y, we can open the bracket over here, so we will get 2 times x multiplied with x plus y is going to be equals to 2x square plus 2 times xy. Okay, so we have this particular equation. Now from both the sides we can cancel out 2xy and 2xy. X square from the left hand side shifted over here becomes negative x square, so 2x square minus x square becomes x square, and over here y square plus y square becomes 2 times y square. Now I will simply divide both the sides by y square, so I will get that x square upon y square is going to be equals to 2, and upon 1 we can say. So x square upon y square is 2 upon 1, and that's the answer that we were looking for. Remember that the required ratio, that is the area of the yellow square to the area of the red square, was ultimately x square upon y square. Here is that particular thing we have discussed in the beginning of the video. To get the required ratio, we have to ultimately find the value of x square upon y square, and we have did it over here. So we can write the final answer, that is the ratio is going to be equals to 2:1, and that's the answer. So this was my way to solve this particular question. If you have any other method other than this, you can do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram or Discord. The links are in the description.